Good afternoon. My name is Theodoros Spyridopoulos. I'm from Cardiff University, and I'm going to present you our project on Federated HPC architectures for AI workflows in privacy-sensitive and real-time domains. Our project is a collaboration between Cardiff University and Newcastle University. We have a long list of members included in the project. Most of us are also part of the Edge AI Hub project that is focusing on security in Edge AI. In fact, Professor Rajiv from Newcastle University is the director of the Edge AI Hub. And I think we've got here Tomas over there from Newcastle, who is leading from Newcastle side this project. I think you are representing the hub today, yeah? So before I talk about the actual project, I wanted to start with some context about the Edge. And I will rely on a past project to do that. So that project was Synergia, and it was focusing on the security of an Edge AI platform. That platform comprised over 200 sensing nodes that were installed on lampposts across a 7.2-kilometer road in Bristol. Each node had a variety of sensors, environmental sensors, like CO2, humidity, temperature, etc. And they could also record videos. Now, some of these sensors, almost half of them, had also some AI capability. They had a GPU on them, on the lamppost, that was able to process data on the device. Now, as I said, our project back then was focusing on the security of the system, and one of the tasks was to build an intrusion detection system that works on the device. Yeah. So an idea would be to train the system offline, deployed online, but everyone knows that, in most cases, whatever you train offline does not perform as well when it's deployed online. So next attempt would be to train an AI model offline and further train it with frequent data collection from all these devices. But of course, that includes increased latency, increased bandwidth consumption, overheads, data communication overheads. And of course, in some cases, because these nodes were recording video as well, it might also have some privacy implications. So the answer to this issue was to train the model offline first, then deployed online on the devices, and then on each one of these devices perform some further training, using a federated learning approach. Each of the devices was collecting data, system data from the operating system and from the applications that were running on the device. And we used this data. This data was collected the Edge AI nodes, pre-processed there. Then an autoencoder, that's the model that we initially trained offline. An autoencoder was used for inferencing purposes. So that was the first stage. Now, for data samples that produced a high confidence score, we used these data samples to do some further training on that device. So in other words, each one of these 100 Edge AI nodes had a somewhat tweaked version of our initial model, a fine-tuned version of the initial model based on the data they were collecting. And we used federated learning in order to aggregate this knowledge into one unique global model that was then deployed on all devices. So the advantages of that is that you don't need to collect the data centrally. You train on the device. And of course, there's no privacy violation because everything is done on the device. For low confidence scored outputs, we send them to a human expert centrally. So that was the only case that we collected data centrally. So that's how we consider the edge. It's processing that is close to where the data is generated. There are many applications that have real-time decision-making and privacy-preserving computation as key requirements. There are applications that also include resource-heavy computation, the requirement for resource-heavy computations. And we have identified, within the context of this project, two areas: healthcare and transport system simulations, or transport systems. So in healthcare, we envisage applications where local trusted research environments where healthcare data is generated and anonymized, they allow researchers to analyze this data. However, by federating TREs with the HPC, we would be able to allow a researcher to exploit the resources, the HPC resources, in order to train a very large, for example, deep neural network based on data collected from different TREs. In transport systems, we could, for example, combine digital twins that rely on data that are collected from the infrastructure, so real-time data, with very large simulations that are executed in the HPC. And as a result, we can come up with real-time traffic modeling. So HPC provides large-scale processing power. However, we also need to integrate it with the local edge infrastructure. In order to enable rigorous and replicable research experiments, we also need to consider scientific workflows. Yeah. For that reason, we need to consider the workflows that can be deployed over this heterogeneous system. We have different edge infrastructure and the HPC. So there is a clear need to explore the feasibility of edge, whatever edge means. Yeah, there are many different meanings to what edge is, and HPC Federation and HPC. So the aims of this project is to evaluate the feasibility of federating HPC, and in particular, we want to rely on Isambard AI, but that comes with question mark, and some local edge infrastructures that we have at Newcastle University and Cardiff University. We will build a user or a stakeholder community in healthcare and transportation. We want them to inform our workflows and together design the workflows. And we will develop and test these workflows across the edge HPC continuum. And through this process, identify technical and policy barriers to the federation. So I've got the QR code up here for those of you who are interested in this, in getting involved in these workshops. Please scan the QR code and provide your details, and we will contact you to get you involved in these workshops, as I said. So our project relies on two pillars, community pillar and the technology pillar. At the community level, we will organize 3 workshops with the stakeholders in order to identify these workflows, the user narratives that will define the workflows. We already have the partners from the Edge AI Hub, industry partners from the Edge AI Hub. We have also identified the Dare UK projects that we think might be interested in our work as well. We have not talked with them yet, but the plan is to include them. At the technology level, we plan to build a testbed that integrates edge infrastructure that we have at the Newcastle and Cardiff with the HPC, Isambard AI in our case. We plan to validate the AI workflows on the testbed and explore through this process on privacy-preserving on decentralized approaches in AI computation. This is an example of a workflow. Now, imagine that the endpoint in this case is a sensor that is used by a patient. Yeah, so that sensor generates data. This data is collected at the edge. In this particular example, the edge is represented by a TRE. So the TRE is collecting data from the sensors or any device that the patient wears. Using this data, a researcher can develop synthetic data generators at the edge, so within the TRE environment, according to the TRE policies that are defined by the Dare UK project. The next step would be to use multiple synthetic data generators in order to generate a very large data set of synthetic data in the HPC. So at the HPC level, we collect the data generators. We can generate large data sets, train deep neural networks, and then again, depending on the use case. So in this particular scenario, we thought that it might be a good idea to deploy the model on the sensor device at the end. So there is another step, model distillation, where we go from the very large model on the HPC to a smaller version of it that can be deployed on the device. This is just an example, but this is what we want to achieve. This is what we want to define through these workshops and with the use of the user narratives. Of course, we need to transform this workflow into a scientific workflow that can be easily replicated and deployed on the heads HPC continuum. So back to the workshops. We will have 3 workshops throughout the year. The first one is going to be in October, November time. Again, we have not defined the exact date yet, but for those of you who are interested, you can always provide your details and we will keep you updated. There will be 2 other workshops, one in January and another one in March. The purpose of these workshops, as I said earlier, is to define the user narratives that will help us to design the workflows, later develop and test them on our testbed. So that was it, pretty much. Thank you.